Asymmetry is the absence of, or a violation of, symmetry. Symmetry is an important property of both physical and abstract systems, and it may be displayed in precise terms or in more aesthetic terms. The absence of violation of symmetry that are either expected or desired can have important consequences for a system. In organisms, due to how cells divide in organisms, asymmetry in organisms is fairly usual in at least one dimension, with biological symmetry also being common in at least one dimension. Louis Pasteur proposed that biological molecules are asymmetric because the cosmic, that is physical forces that preside over their formation are themselves asymmetric. While at his time, and even now, the symmetry of physical processes are highlighted, it is known that there are fundamental physical asymmetries, starting with time. Usefulness to organisms, asymmetry and important evolutionary traits, such as the left human lung being smaller, and having one fewer lobes than the right lung to make room for the asymmetrical heart. Handedness is an asymmetry in skill development in people and animals. Training the neural pathways in a skill with one hand takes less effort than doing the same with both hands. Nature also provides several examples of handedness in traits that are usually symmetric. The following are examples of animals with obvious left-right asymmetries. Fiddler crabs have one big claw and one small claw. The narwhal's tusk is a left incisor which can grow up to 10 feet in length and forms a left-handed helix. Flatfish have evolved to swim with one side upward, and as a result have both eyes on one side of their heads. Several species of owls exhibit asymmetries in the size and positioning of their ears, which is thought to help locate prey. Phylum Porifera consisting of sponges are part of a small minority of species demonstrating almost no body symmetry. They are instead evolved for maximal efficiency of water flow through their central cavity. As an indicator of unfitness, certain disturbances during the development of the organism, resulting in birth defects. Injuries after cell division that cannot be biologically repaired, such as a lost limb from an accident. Since birth defects and injuries are likely to indicate poor health of the organism, defects resulting in asymmetry often put an animal at a disadvantage when it comes to finding a mate. In particular, a degree of facial symmetry is associated with physical attractiveness, but complete symmetry is both impossible and probably unattractive. In structures, pre-modern architectural styles tended to place an emphasis on symmetry, except where extreme site conditions or historical developments lead away from this classical ideal. To the contrary, modernist and postmodern architects became much more free to use asymmetry as a design element. While most bridges employ a symmetrical form due to intrinsic simplicities of design, analysis and fabrication and economical use of materials, a number of modern bridges have deliberately departed from this either in response to site-specific considerations or to create a dramatic design statement. Some asymmetrical structures. In mathematics, there are no A and B such that A, B and B, A. This form of asymmetry is an asymmetrical relation. In chemistry, certain molecules are chiral. That is, they cannot be superposed upon their mirror image. Chemically identical molecules with different chirality are called enantiomers. This difference in orientation can lead to different properties in the way they react with biological systems. In physics, asymmetry arises in physics in a number of different realms. Thermodynamics, the original non-statistical formulation of thermodynamics was asymmetrical in time. It claimed that the entropy in a closed system can only increase with time. This was derived from the second law and using the Clausius theorem. The later theory of statistical mechanics, however, is symmetric in time. Although it states that a system significantly below maximum entropy is very likely to evolve towards higher entropy, it also states that such a system is very likely to have evolved from higher entropy. Particle physics. Symmetry is one of the most powerful tools in particle physics, because it has become evident that practically all laws of nature originate in symmetries. Violations of symmetry therefore present theoretical and experimental puzzles that lead to a deeper understanding of nature. Asymmetries in experimental measurements also provide powerful handles that are often relatively free from background or systematic uncertainties. Parity violation. Until the 1950s, it was believed that fundamental physics was left-right symmetric. That is, that interactions were invariant under parity. Although parity is conserved in electromagnetism, strong interactions and gravity, it turns out to be violated in weak interactions. The Standard Model incorporates parity violation by expressing the weak interaction as a chiral gauge interaction. Only the left-handed components of particles and right-handed components of antiparticles participate in weak interactions in the Standard Model. A consequence of parity violation in particle physics is that neutrinos have only been observed as left-handed particles. In 1956–1957 Kai-and Xian-Wu, E. Ambler, R. W. Hayward, D. D. Hobbs, and R. P. Hudson found a clear violation of parity conservation in the beta decay of cobalt-60. Simultaneously, R. L. Garwin, Leon Lederman, and A. Weinrich modified an existing cyclotron experiment and immediately verified parity violation. CP violation. After the discovery of the violation of parity in 1956–57, it was believed that the combined symmetry of parity and simultaneous charge conjugation, called CP, was preserved. For example, CP transforms a left-handed neutrino into a right-handed antineutrino. In 1964, however, James Cronin and Val Fitch provided clear evidence that CP symmetry was also violated in an experiment with neutral quarons. CP violation is one of the necessary conditions for the generation of a Burien asymmetry in the universe. Combining the CP symmetry with simultaneous time reversal produces a combined symmetry called CPT symmetry. CPT symmetry must be preserved in any Lorentz invariant local quantum field theory with a Hermitian Hamiltonian. As of 2006, no violations of CPT symmetry have been observed. Burien asymmetry of the universe. The baryons observed in the universe are overwhelmingly matter as opposed to antimatter. This asymmetry is called the Burien asymmetry of the universe. Isospin violation. Isospin is the symmetry transformation of the weak interactions. The concept was first introduced by Werner Heisenberg in nuclear physics based on the observations that the masses of the neutron and the proton are almost identical and that the strength of the strong interaction between any pair of nucleons is the same, independent of whether they are protons or neutrons. This symmetry arises at a more fundamental level as a symmetry between up-type and down-type quarks. Isospin symmetry in the strong interactions can be considered as a subset of a larger flavor symmetry group, in which the strong interactions are invariant under interchange of different types of quarks. Including the strange quark in this scheme gives rise to the eightfold way scheme for classifying mesons and baryons. Isospin is violated by the fact that the masses of the up and down quarks are different, as well as by their different electric charges. Because this violation is only a small effect in most processes that involve the strong interactions, isospin symmetry remains a useful calculational tool, and its violation introduces corrections to the isospin symmetric results. In collider experiments, because the weak interactions violate parity, collider processes that can involve the weak interactions typically exhibit asymmetries in the distributions of the final state particles. These asymmetries are typically sensitive to the difference in the interaction between particles and antiparticles, or between left-handed and right-handed particles. They can thus be used as a sensitive measurement of differences in interaction strength and/or to distinguish a small asymmetric signal from a large but symmetric background. A forward-backward asymmetry is defined as AFB equals NFNB / NF plus NB, where NF is the number of events in which some particular final state particle is moving forward with respect to some chosen direction, while NB is the number of events with a final state particle moving backward. Forward-backward asymmetries were used by the LEP experiments to measure the difference in the interaction strength of the Z boson between left-handed and right-handed fermions, which provides a precision measurement of the weak mixing angle. A left-right asymmetry is defined as ALR equals NLNR / NL plus NR, where NL is the number of events in which some initial or final state particle is left polarized, while NR is the corresponding number of right polarized events. Left-right asymmetries in Z boson production and decay were measured at the Stanford Linear Collider using the event rates obtained with left-polarized versus right-polarized initial electron beams. Left-right asymmetries can also be defined as asymmetries in the polarization of final state particles whose polarizations can be measured. For example, tau leptons. A charge asymmetry or particle-antiparticle asymmetry is defined in a similar way. This type of asymmetry has been used to constrain the Parton distribution functions of protons at the Tevatron from events in which a produced doubly boson decays to a charged lepton. The asymmetry between positively and negatively charged leptons is a function of the direction of the doubly boson relative to the proton beam, provides information on the relative distributions of up and down quarks in the proton. Particle-antiparticle asymmetries are also used to extract measurements of CP violation from B meson and anti-B meson production at the Barber and Bell experiments. Lexical asymmetry is also relevant to grammar and linguistics, especially in the contexts of lexical analysis in transformational grammar. Enumeration example: in English, there are grammatical rules for specifying coordinate items in an enumeration or series. Similar rules exist for programming languages and mathematical notation. These rules vary, and some require lexical asymmetry to be considered grammatically correct. For example, in standard written English, we sell domesticated cats, dogs, and goldfish. Inline asymmetric and grammatical, we sell domesticated animals. Inline symmetric and grammatical, we sell domesticated animals. Inline symmetric and ungrammatical, we sell domesticated animals. Outline symmetric and grammatical, cats, dogs, goldfish. Other uses: asymmetric gameplay is a form of multiplayer in video games, in which multiple players can play the same game simultaneously in different ways. A strong example of this is Nintendo's Wii U console, which offers asymmetric gameplay experiences via its Wii U gamepad. For example, in Rayman Legends, a player using a standard controller can control the on-screen character, whilst a second player using the Wii U gamepad's touchscreen can control an extra character that can manipulate the environment. Another good example is the upcoming multiplayer game Evolve, which pits a team of 4 player-controlled hunters against a 5th player, who controls a giant monster character. See also, information asymmetry, asymmetric multiprocessing. References: Introduction to Set Theory, 3rd edition, revised and expanded, Basic, J.H. Further reading: Gardner, Martin, The New Ambidextrous Universe, Symmetry and Asymmetry from Mirror Reflections to Superstrings, 3rd edition, W. H. Freeman and Company Limited. Yeo-Nung Jan and Lily A. Jan, 1999. Asymmetry Across Species. Nature Cell Biology 1, E42, E44 PMID 10,559,895.